In 1993, three engineers made a bet on a technology that didn't exist yet, and every expert said the company would fail. Today, that company is Nvidia, one of the most powerful companies on Earth, and the engine behind the entire AI revolution. But what most people don't know is that Nvidia almost died, multiple times. And the decision that saved the company was so insane that even Nvidia's own engineers thought it would destroy them. Because once you understand the bet Jensen Huang made, you'll see why Nvidia didn't just survive the AI boom. It created it. But before Nvidia powered artificial intelligence, before it powered systems like ChatGPT, and long before it became a multi-trillion-dollar company, the entire story began in a place that seemed completely ordinary. A late-night conversation inside a diner. The Denny's origin story. The year is 1993, and Silicon Valley is obsessed with one thing: CPUs. The central processing unit is considered the heart of every computer, and companies like Intel dominate the conversation. Engineers, investors, and analysts all believe that the future of computing will continue to revolve around faster and more powerful CPUs. Jensen Huang sees the industry from a different angle. While many engineers focus on general-purpose processors, Huang begins thinking about the growing importance of computer graphics. Video games are becoming more sophisticated, 3D graphics are improving rapidly, and computers are starting to display far more complex images than ever before. Rendering those graphics requires enormous computing power. Huang believes a specialized processor designed specifically for graphics could handle those calculations much more efficiently than a traditional CPU. To explore this idea, Huang begins meeting with two engineers he respects deeply, Chris Malachowski and Curtis Preem. The three engineers share similar experiences in the semiconductor industry, and each one understands how quickly computing technology can evolve. Their conversations often happen at a Denny's restaurant in San Jose. Sitting in a booth surrounded by coffee cups and notebooks, they discuss the future of computing late into the night. Eventually, they make a decision that will change their lives. They will start a company focused entirely on building powerful graphics processors. Jensen Huang believes graphics will become the language of modern computing. As visual experiences improve, he believes computers will rely heavily on processors designed specifically for rendering complex images. He didn't just see the future, he created it. With that belief guiding them, the three founders launch a company called Nvidia. The vision sounds exciting, but the first years of the company are extremely difficult, and the entire startup almost disappears before the idea ever proves itself. The crisis that nearly ended everything. Only a few years after launching, Nvidia faces a serious problem. The company releases one of its early graphics chips, expecting it to compete in the growing PC graphics market. Engineers have spent countless hours developing the product, and the company depends heavily on its success. Unfortunately, the chip struggles in the market. Developers find it difficult to use, and its performance does not meet expectations. Customers hesitate to adopt the technology, and the product fails to gain the momentum Nvidia desperately needs. Inside the company, the pressure grows quickly. Cash reserves begin shrinking, and executives realize the startup may not survive if the situation continues. Difficulty strikes and layoffs begin as Nvidia attempts to conserve money and extend its runway. At one point, the company has only enough money to cover about a month of payroll. Many startups reach this stage and rapidly shut down. Jensen Huang responds with a decision that surprises almost everyone inside the company. Instead of making small improvements to the struggling product, he cancels the entire architecture behind it. The engineering team receives crazy instructions. They must build an entirely new graphics chip from the ground up. This felt like a sinking ship moment for most. Months later, Nvidia released a new graphics chip called the Riva 128. This time the market reacts differently. The product performs well, gamers embrace the technology, and PC manufacturers begin integrating Nvidia graphics into their systems. The success of the Riva 128 gives Nvidia its first real breakthrough. The company survives its early crisis, and Jensen Huang walks away from the experience with an important lesson. Graphics cards bring Nvidia success in gaming, but Jensen Huang soon begins noticing a strange trend that will shape the company's future in an unexpected way. When researchers discovered GPUs, as the late 1990s and early 2000s unfold, Nvidia becomes widely known for producing powerful graphics cards used in gaming computers. Gamers appreciate the improved visuals, and the company continues refining its technology with each new generation of graphics processing units (GPUs). During this period, something unusual begins happening inside universities and research laboratories. Scientists start experimenting with Nvidia GPUs for tasks that have nothing to do with graphics. Researchers discover that GPUs can perform thousands of small calculations at the same time. This ability makes them extremely useful for complex computational tasks such as physics simulations, climate modeling, and data analysis. Slowly, researchers begin testing GPUs for early machine learning experiments as well. Training neural networks requires enormous computational power, and GPUs handle these calculations far more efficiently than traditional CPUs. Jensen Huang pays close attention to these developments. While many technology companies continue focusing almost entirely on CPUs, Huang begins investing in tools that allow developers to program GPUs for many different purposes. One of the most important developments is CUDA, a programming platform that allows researchers and engineers to unlock the full computing power of Nvidia GPUs. At the time, the strategy appeared uncertain. Gaming remains Nvidia's main business, and investing heavily in new software ecosystems carries financial risk. But Huang believes the long-term opportunity could be enormous. For several years, the payoff remains unclear. Then, artificial intelligence begins moving from academic research into real technology products. The bet on artificial intelligence. During the early 2010s, breakthroughs in artificial intelligence begin attracting attention across the technology industry. Researchers working with neural networks start achieving impressive results in image recognition, speech processing, and data analysis. Training these AI models requires extraordinary computing power. Massive data sets must be processed through billions of calculations during the training process. GPUs turn out to be perfect for the job. Researchers increasingly rely on Nvidia hardware to train their machine learning models. Jensen Huang sees this trend growing and decides to invest aggressively in AI computing. The company began designing GPUs specifically optimized for artificial intelligence workloads. Nvidia also expands its software tools, so developers can easily train and run machine learning systems on its hardware. The strategy requires billions of dollars in investment, and the market response remains uncertain for years. Artificial intelligence still appears experimental to many observers, and some analysts question whether Nvidia is spending too much money chasing an unclear opportunity. Huang remains confident that AI will eventually transform computing. Around 2022, the world suddenly begins paying attention to artificial intelligence. Breakthroughs in generative AI capture global attention as new tools demonstrate impressive capabilities in language generation, image creation, and data analysis. Training these advanced models requires massive computing infrastructure. Companies around the world search for the hardware capable of powering this new generation of AI systems. Many of them turn to the same company, Nvidia. The GPUs that Jensen Huang invested in for years became the backbone of the modern AI industry. Technology companies purchase thousands of these chips to build powerful data centers capable of training and running artificial intelligence models. Demand for Nvidia hardware rises dramatically. The company's revenue grows rapidly, and its market value climbs into the trillions. The startup that once struggled to survive becomes the most important supplier of computing power for the AI revolution. Jensen Huang, the engineer who once pitched a graphics startup inside a diner booth, becomes one of the most influential leaders in the technology world. Nvidia became a trillion-dollar company because it repeatedly bet on technologies before the rest of the world recognized their importance. First graphics processing, then parallel computing, and finally artificial intelligence. And right now, somewhere inside Nvidia headquarters, Jensen Huang is already preparing the next bet that could shape the future of computing